Welcome my dear students. Today we will see the next devices which are based upon the Bernoulli's equation, okay, that is orifice meter, or it is also called as what? Orifice plate. So this is the diagram of the orifice meter, okay. So it is also a device used for measuring the rate of flow of a fluid through a pipe. So what is the rate of flow? It is Q. It is also a device used for measuring the rate of flow of a fluid through pipe. So it is cheaper device. It is a cheaper device as compared to the venturi meter. It also works on the same principle as that of venturi meter. That is what? That is Bernoulli's equation, right? So here this is the figure of this orifice meter. So practically it will be like this, but here also we will have some problems on this. So we have to derive the equation for what? Q. Okay. So for that we will use the schematic representation of this orifice meter. So about this figure or this orifice meter, what we can tell is, so this orifice meter, it consists of a flat circular plate which has a circular sharp edged hole called orifice, okay, which is concentric with the pipe. So the orifice diameter is kept generally 0.5 times diameter of the pipe, though it may vary from zero point 0.4 to zero point 0.8 times of the pipe diameter. So this is the orifice meter. So this is how it represents. Okay, it has the sharp circular edge hold. Okay, so which is concentric with this pipe. Now we will see its schematic representation. So this is the pipe. So pipe is continuous, whereas where the orifice meter is there, no, there it is cutted. Okay, so direction of flow of liquid. So section 1, section 2, same as we did in the venturi meter, no, same method, just we have to take here some more terms with related to the orifice meter. Okay, so this is the orifice meter and this is the pipe. So a differential manometer is connected at section 1, okay, which is at a distance of about 1.5 to 2 times the pipe diameter upstream from the orifice plate, and at a section 2 which is at a distance of about half the diameter of the orifice on the downstream side from the orifice plate. Okay, the plate is nothing but this orifice meter only. So this is at section 1 and this is at section 2. So due to this orifice meter, the flow will be like this. I'll take different color. See the flow will be like this, some vena contracta type occurs, okay, due to the orifice meter. So now what we have to do, now here also we will derive by assuming some of the terms, that is pressure, velocity and area at section 1 and at section 2. So we will apply the Bernoulli's equation as we did in the venturi meter, and we will find the equation for Q, and that we will use for what? Any problem which will come here based on the orifice meter, right? So we'll start our derivations. So let P1 is the pressure at section 1 here, and V1 is the velocity at section 1, and area is the A1 is the area of the pipe at section 1. Similarly, we have to take P2 is at a pressure at section 2, V2 is at a section, V2 is the velocity at section 2, and A2 are the area of the pipe at section 2. Okay, now what we have to do next step is we should apply the Bernoulli's equation at section 1 and 2. So we get what? P1 rho g plus P1 square by 2g plus Z1, which is equal to P2 by rho g plus V2 square by 2g by plus Z2. So same which as we did in the venturi meter. Okay, so now what we do, we will rearrange the terms. Okay, if here P1 by rho g plus Z1, this term P1 by rho g plus Z1, minus we will take this term P2 by rho g plus Z2 is equal to V2 square by 2g minus V1 square by 2g. So why we did like this? Because we want this we want to calculate what this V1 and V2 first of all, and then this difference in pressure rates we can take it as what H. That's why we took like this. So now what we can tell, sorry, P1 by rho g plus Z1 minus P2 by rho g plus Z2 is equal to what H. It is the differential head. Okay, so as it is horizontal, we could take Z1 is equal to Z2 and we should cancel. No, here that will not happen because the water will flow like this. No, there is a plate. Okay, it has a different theory. Okay, we will discuss it sometime. Okay, so P1 by rho g plus Z1 minus P2 by rho g plus Z2 is equal to what this differential head. Okay, so now what happens, this H is equal to what V2 square by 2g minus V1 square by 2g. Okay, then we will transfer that 2g that side, that is 2gh is equal to V2 square minus V1 square. So we will find the value of this V2 square, that is V2 square is equal to V2 square is equal to what, V2 square is equal to 2gh plus V1 square. So V2 is equal to root of 2gh plus V1 square. Okay, so now we find out the value of what V2. So we'll take this as equation number 1. Okay, so now section 2, I'll show you. At section 2, what we can see is at a vena contracta. Okay, now section is at a vena contracta. So this term or this method of flowing water, it's termed as vena contracta. Okay, and A2 represents the area at the vena contracta. Okay, here particularly. Okay, so section 2 is at vena contracta where it is. Okay, then A2 is represents the area at the vena contracta and A0 is the area of the orifice. Okay, area A0 be the area of the orifice. So we have a new term, that is CC. Okay, so this is nothing but what is happening here, contraction is happening, right? Okay, so first here contraction is happening, then it is diverging. Okay, so with the point where the converging turns to diverging, so it is called as vena contracta here. Okay, so A0 is what is the area of the orifice. Okay, so A2 is what area represented at the vena contracta. So we will have a coefficient there. What is that coefficient? So coefficient of contraction, CC, that is coefficient of contraction is equal to what A2. So area at a section where it represents the vena contracta divided by A0. A0 is what area at the orifice, area of the orifice, where CC is what coefficient of contraction. Okay, so from this term what we can find, we can find the value of A2, that is A2 is equal to what A0 into CC. So what is A2? It is the area at the vena contracta is equal to area of the orifice into the coefficient of the contraction. We will get this area. Okay, so we don't have any formula to find here. That's why we followed this type. We followed this method to find this A2. So once we got A2, what we know? We know the continuity equation, that is A1 V1 is equal to A2 V2. Okay, so from here what we have now? We know the value of what V2. Okay, so V1 is equal to what? So we know V2. So V1, I want term for V1. So V1 is equal to A2 into V2 divided by A1. Okay, so that is equal to what is the value of A2? So A2 I'll substitute, just it's simple mathematics. Okay, so A0 CC divided by A1 is equal to into V2. So at last V1 is equal to what? A0 CC divided by A1 into V2. This is the V1. Okay, now what we'll do, we will substitute this V1. Okay, substituting the value of V1 in equation 1, that is which we took here now, this one. So substituting the value of V1 here, so what we will get? We will get the value of V2, right? See, so V2 is equal to what? Root 2GH plus V1 square into So V1 square into, so I am substituting this value, that is A naught square Cc square V2 square divided by A1. Okay, so now what we are doing, so just we will simplify, that's it. It's just simple mathematics, just you have to know the concept where and what we have to do. So continuity equation use ಮಾಡಬೇಕು. So next procedure ಏನು, ವಿನಾ ಕಾಂಟ್ರಾಕ್ಟರ್ ಹತ್ರ ಏರಿಯಾ ತಗೋಬೇಕು. Just you conceptually you understand, then just is a simple mathematics. So once we got this V2, simplify this term. So V2 square is equal to what? 2GH. Okay, so plus A naught by A1 whole square, Cc square V square, or V2 square into, so I will taking a term, common term, so 1 minus A naught by A1 whole square into Cc square is equal to what? 2GH. Okay, so V2 square is equal to what? 2GH plus A naught A1 whole square into Cc square V square. So this is the term, don't get confused. Okay, or they can, what they can do, they can remain this 2GH here only, and they all shift this term, shift this term to this side. They are just what? Shifting this term to this side. What it happens? So V2 square, it is plus is there, no, minus A naught by A1 whole square Cc square V2 square. So then V2 same. Okay, so we will take common V2 term, so V2 square into 1 minus A naught by A1 whole square Cc square is equal to what? 2GH. So this equation we get. Okay, so once we got this equation, so V2 square is equal to what? Divided by V2 square is equal to 2GH divided by this term will send here. So multiplication becomes what? Division. V2 square is there, so only what we need only V2. So V2 is equal to what? Root 2GH divided by root of 1 minus A naught by A1 whole square into Cc square. Okay, so we got V2 value, and we know the A2 value. Okay, so what is the term now? Now what we will take? We will take the discharge Q1. Q is equal to what? A2 into V2. Okay, so the discharge is equal to Q is equal to V2 into A2, that is V2 into the term A2 is what? By the formula of Vina contract, that is A naught into Cc. Okay, so A naught into this Q is equal to, so I'll substitute the term of V2 here only. See here, this term I'll writing. Okay, so just we have to substitute, that's it, there is no, so 2GH, so this is the term V2. Okay, V2 into A naught into Cc. Just I wrote in the place of V2, I substituted the value of V2. So Q is equal to what? A naught into Cc root 2GH divided by root of 1 minus A naught by A1 whole square into Cc square. Okay, so this above equation is simplified by using some of the important terms, that is called as Cc, that is coefficient of contraction. Then we will get a value, that is, see here, they are telling A2 is equal to what? A naught into Cc. Okay, fine. So the above expression is simplified by, so we know the formula, that is CD is equal to, okay, CD means the coefficient of discharge for orifice meter. We have a formula, that is CD is equal to Cc root of 1 minus A naught by A1 whole square divided by root of 1 minus A naught by A1 whole square into Cc square. Okay, so what we need the value of Cc, right? So what I'll do, I retain the Cc here and I'll transfer this term to this side, so it will become what? Reciprocal. Okay, so Cc is equal to CD root of 1 minus A naught by A1 whole square into Cc square divided by root of 1 minus A naught by A1 whole square. Okay, now I'll do substitute this value Cc in the value of the discharge Q. Okay, so Q is equal to A naught into CD. Okay, A naught into CD. CD is what? In the place of Cc I am writing CD root of 1 minus A naught by A1 whole square into Cc square divided by root of 1 minus a naught by a1 whole square into root 2gh into root of 1 minus a naught into a1 whole square into cc square. This is what? V2. So simplifying we'll get what? Q is equal to what? CD into a naught a1 divided by root 2gh divided by a1 square minus a2 a naught square. So CD is what? Coefficient of discharge for Orifice meter. So this coefficient of discharge for Orifice meter is much smaller than that of the Venturi meter. The coefficient of CD for discharge meter is much smaller than that of the Venturi meter. So this is the expression for Q, which we should remember in case of what? The Orifice meter. Okay, CD into A naught A1 into root 2gh divided by square root of A1 square minus A naught square. So just derive once, twice, thrice you write. So you will get the terms. And about this CC and CD, we will see in the clearly about them in the next chapter, that is more Orifice in the in your module 4 we will learn about them. Okay, so till then you just practice it, write it so that you are comfortable with that. So next we will see the pitot-tube. Okay, so it is the last device which is in our syllabus based on the Bernoulli's equation. So it is also a device used for measuring the velocity of flow at any point in a pipe or a channel. Okay, so this is the digital pitot meter and this is the, it is not digital. Okay, so now it's a device used for measuring the velocity of flow at any point in a pipe or a channel. Okay, so it is based on the principle that if the velocity of flow at a point becomes zero, if the velocity of flow at a point becomes zero, then the pressure there is increased due to the conversion of kinetic energy into pressure energy. If suddenly the velocity of water, the velocity of flow, okay, at a point becomes zero means, so where the flow again karana kinetic energy karana tane, so a kinetic energy sudden agi stop aitandre enagutte, okay, the pressure there is increased, the pressure there ಅಲ್ಲಿ ಎಲ್ಲಿ ಸ್ಟಾಪ್ ಆಗಿರುತ್ತೋ ಅಲ್ಲಿ, the where it is stopped there the pressure will be increased. Why? Because it is stopped. No, the kinetic energy is converted into pressure energy. The kinetic energy is converted into pressure energy, so it is based upon that principle. This is the pitot tube. So schematically we will represent the pitot tube like this. Okay, so h is, this is the head under the water or above the flow. Okay, so section 1 and section 2. So this is the schematic representation of the pitot tube. So now we will see some of the theory points. So in its simplest form, the pitot tube consists of a glass tube bent at right angles. See here. Okay, this is the part of pitot tube. Okay, so here it is the simplest form. The pitot tube consists of a glass tube bent at right angles as shown in figure. So the lower end, which is bent through 90 degrees, is directed in the upstream direction as shown in figure. I'll show you the figure. Liquid rises up in the tube due to the conversion of kinetic energy into pressure energy. The liquid rises up means where the flow of fluid will be stopped. So due to that, the liquid rises up in the tube because it is 90-degree bend. No, so like this will be there. Okay, like this bend will be there. Okay, so whenever it comes, so this flow will be stopped completely. So when it is stopped, the kinetic energy is converted into pressure energy, right? So due to that, the velocity is determined by measuring the rise of a liquid in the tube. The rise of a liquid in the tube. See here, this is the figure. Now once again we will discuss about that. Once again I'll read out so that you will get confirmed. See here, simplest form, the pitot tube consists of a glass tube bent at right angles as shown in figure. Okay, so the lower end, which is bent through 90 degree, so it is the lower end which is bent through 90 degrees, directed in the upstream direction. Upstream direction means where the flow is starting. Okay, so this is the downstream side. Okay, the liquid rises up in the tube. So whenever the liquid comes here, it rises up in the tube. Okay, due to the conversion of this kinetic energy into the pressure energy. Okay, so the velocity is determined by this head, determined by measuring the rise of the liquid in the tube. Okay, so this is the principle behind this pitot tube. Now what we do, we will also find an equation for this. So consider 2 points 1 and 2 at the same level in such a way that point 2 is just as the inlet of the pitot tube and point 1 is far away from the pitot tube. So point 2 is the inlet and point 1 is far away from the tube. We will consider this condition before we derive the equation for this. So small equation, okay. So next what we do, we will find the equation. So let what is the routine equation, that is terms. Let P1 is the intensity of pressure at a point 1, V1 is the velocity at flow, P2 is the pressure at point 2, V2 is the velocity at point 2, which is 0. Okay, so at V2 only it becomes 0. H is the depth of the tube in the liquid and H is the rise of the liquid in the tube above the free surface. Okay, so I just uh, told what is there in the diagram. Now what we do, we should apply what? Bernoulli's equation at point 1 and 2. Same. So P1 by rho g plus V1 square by 2g plus Z1, P2 by rho g plus V2 square by 2g plus Z2. Same. So Z1 and Z2 are what? At the same level. So Z1 and Z2 are same line and V2 at 2 is 0. Okay. So P1 by rho g is pressure head at 1 H. P1 by rho g is pressure head at section 1 and P2 by rho g is pressure head at section 2, that is H plus H. Due to the stopping at 2 only, this H will rise. That's why pressure head at section 2 is what? H plus H. Pressure head at section 1 is what? H. Okay. Substituting these values. Okay. Wait. Substituting these values. Here same it is repeated. Okay. Okay. Substituting these values. Which values? The P1 by rho g is H. Okay. And P2 by rho g is what? H plus H. Substituting these values in the equation, in what? Which equation? Bernoulli's equation, that is P1 by rho g is what? So I'll show you. So P1 by rho g is what? H. Okay. So P2 by rho g is what? H plus H. So this, in this equation we are substituting. So H plus V1 square by 2g is equal to H plus H. Okay. So what we want? We want this small h. So H is equal to what? V1 square by 2g, or V1 is equal to what? 2gh. This h and this cancels. So H is equal to V1 square by 2g. So what we want? We need the V1 square. So V1 is equal to what? Root 2gh. So this is the theoretical velocity, and according to the theory and according to the formulas, this is the velocity, but actual velocity will be low, right? So V1 actual is equal to what? CV, where CV is the what? Coefficient of pitot tube. Okay, so V1 actual, so actual velocity is given by CV into root 2gh. So velocity at any point in the pitot tube can be given as what? V is equal to CV into root 2gh. Okay, then Q is equal to A1 V1 you can do, and you can find out the area, no problem. Area of the pipe into velocity, will get the value of Q is equal to what? So area into velocity, if you do, you will get the discharge value. So here the main point was to find the velocity. Okay, so this velocity of flow in a pipe by pitot tube, we will have some cases. Okay, we will discuss about them now. Okay, so we find now what is the velocity at any point in a pitot tube, that is V is equal to CV into root 2gh. Remember this point. So next, so velocity of flow in a pipe by pitot tube. Okay, so we have three cases, four cases. So we will discuss about them. So for finding the velocity at any point in a pipe by pitot tube, the following arrangements are adopted. So how the pitot tube should be placed actually? So whenever we need to find the velocity or discharge, how should be the arrangement adopted, we will see. Pitot tube along with the vertical piezometer tube as shown in figure. So we can arrange like this. Okay, piezometer tube is here and pitot tube is here. So this is the arrangement used. This should be followed when the situation or the concept is like this. Okay, so piezometer tube, after that we have to place pitot tube, and H is this, and this is what H, this is section 2 and this is section 1. Okay, so directly use the formula, you will get the values. So second one is pitot tube connected with the piezometer tube as shown in figure. Here pitot tube is connected with the, if suppose you have to connect the piezometer or pitot tube to the piezometer, so this is the arrangement need to be followed. Okay, then pitot tube and vertical piezometer tube connected with the differential U-tube monometer. So when you take monometer is in picture, how we should do. Okay, so this is what, this is the pitot tube. Okay, so this is the piezometer and here the differential U-tube monometer. Okay, so last case is there, that is, so pitot static tube, pitot static tube, so which consists of two circular concentric tubes, one side the other, with some annular space in between as shown in figure. Okay, if you want to place the pitot static tube, so this is the arrangement. The outlet of these two tubes are connected to a differential manometer. Okay, where the difference of pressure head H is measured by knowing the difference of the levels of the manometer liquid, say X. Okay, so what is the formula we've to find H? So in this case we already know. Okay, the outlet of these tubes are connected to a differential manometers where the difference of pressure head is measured by knowing the difference of the levels of the manometer. So that is H is equal to X into Sg by S naught minus 1. Okay, specific gravity of the liquid, we already discussed this. S naught is specific gravity of a liquid flowing through pipe. So Sg is the specific gravity of the liquid wherever it is flowing in this manometer. Okay, and this is the formula for H. So once H is known, we can directly use the formula and we can calculate the discharge of the pitot tube. So these are the four arrangements. So based upon these four arrangements and based upon the formula, you have some of the problems in this pitot tube also. So we will discuss the problems of pitot tube and orifice meter in the next class. So thank you. I'll conclude here my lecture. So if you want any notes regarding this subject or any subject in civil engineering, you can join my telegram channel and you can request there. So thank you, have a great day ahead.